I'm Robin Harris. I write StorageMojo.com. 30 years in the industry, and, well, actually more than 30, but I'd rather just keep it at 30. And I'm here to talk about the dynamics of future storage. Now, I understand this morning you had a lot of discussion about, the here and now. I just want to say that I'm talking about the there and then, and kind of what the dynamics are that I see that are going to shape storage over the next 5 years. And my approach is really around what I call 360-degree analysis, which starts with what are the secular trends that are out there in the world that are affecting IT, affecting everything, and trends that look like they're going to be continuing for the next, unknown number of years. But these are not things like, who's the next teeny bopper pop group, coming out of, who knows where. This is, long-term stuff. And then I also look at applications and, what's happening in the world of applications is going to impact storage in particular. And finally, I look at the technology. And this is a little bit backwards from the way most people do it, because let's face it, the technology is more fun. Most of us are geeks. We love it. So I'm going to go through some secular trends. Sometime in the last year or so, somebody moved from a farm in Suriname to a city and became the person who tipped the world over from being primarily agricultural in its population to primarily urban. Urban societies are still growing very rapidly, and we are never going back to a world where most people work in agriculture. Now, in the United States, this happened, I think it was around 1905. It maybe was a little earlier than that. But, once you move into a primarily urban world, people are much more connected, and there's a lot more that you can do with that. Climate change. I was going to say global warming, but somebody said, oh, no, that's kind of political. If anybody was wondering if there's going to be climate change, it's happening. It's going to keep happening, and science and big data are going to be one of the key ways that we deal with the unavoidable results of our lack of effort to control carbon dioxide in the atmosphere. And of course, related to that, but not totally, is the issue of energy efficiency. We get a lot of the world's energy from a very politically unstable part of the world, where the United States feels compelled to spend, lots and lots of money, trying to control people. And if we can get more energy efficient, this is going to be good for all of us all over the world. Mass customization. And, it's really, I think, back in the 80s, we used to talk about mass customization in manufacturing as a concept where, you'd order exactly the car you wanted, the zebra skin upholstery and the chartreuse paint job and, things like that. But really, I think mass customization has turned into more of a software technology and a software issue. So we're all carrying around our, okay, if I can find it, we're all carrying around our little hand computers, and we all customize those. And the vendors of the applications are trying to get us to, they're trying to create a custom environment for us with our portable machines. Automation everywhere, and I think basically people are getting more expensive, and they keep getting more expensive, so automation makes more and more sense. And then there's what I call the Google effect, which is actually a pretty direct IT kind of thing. Because Google, Amazon, Windows, Azure, Facebook buy millions of servers every year, when they decide they want a particular feature, boom, it shows up on everybody's machines. And we saw this a few years ago when Google started talking about energy efficiency and inefficient power supplies. And within 6 months, all the vendors were going, hey, we have, efficient power supplies. We have, this, that, and the other. So all these people who didn't really care, consumers who didn't really care about energy efficiency, all of a sudden ended up with energy efficient power supplies, which is good for everybody. But if you had just left it up to consumers, instead of, PhDs who are like analyzing this stuff down to the nth degree, it never would have happened. And that's, and that's the Google effect. Applications. So, I just went to the Cloud Expo and I moderated a panel on big data, so I kind of have big data on the brain. But really, I mean, when you've got somebody trying to monetize 1 billion users, that's big data. And it doesn't matter how you slice it, it's creating a demand for a level of infrastructure that we've never seen before. Smartphones and tablets, there's a couple of ways to cut this. One is we're all going mobile, and so there's all the impact on the wireless infrastructure, but it's also the impact on the PC industry. And for the first time in 11 years, we're going to ship fewer PCs this year than we did last year. And I think that's a trend that's going to continue. I mean, I talk to people who are pretty computer literate even. I mean, not just, grandma sending emails to the grandkids, but people who've been in the industry for 25 years and are, fairly heavy users, and they're going, gosh, with my phone, I don't need to log on to my computer anymore. Well, it's, people like that already have computers, but when it comes time to replace computers, they're not going to buy the kind of machines that people have traditionally bought. And then there's issue, and I've got electronic patient record research here, but this is really kind of a stand-in for any kind of really massive scale research. And in the United States, since we just re-elected the president, we're going to continue on with this independent, I forget what they call it, the Independent Payment Advisory Board or something like that. And what those people do, and what they will be doing a lot more of, and what the Veterans Administration has already done over the last 15 years, is we're going to have a lot of electronic patient records, and we're going to be able to conduct large-scale statistical experiments based on treatments that have been given and the results that we've gotten. And the Veterans Administration has already done this. We have millions of veterans in this country. But we're going to expand that over the next 5 years with electronic patient records, thanks to Obamacare. And that kind of research is big data writ large, but there's lots of other areas where we're going to have massive amounts of data. I just did a post on Formula One racing. And Formula One race cars have 130 sensors that are doing telemetry back to the pit during the race, 130 sensors pumping out data back to the pit. They're collecting it, they're comparing it to previous runs, to other cars in their stable. They're running simulations on that data. And that's just F1. Now, if they're doing it in F1, you can bet that in 5 years, we'll be doing a lot more of it in the consumer world. Because, hey, once you've figured out how to do it with chips, you just got to buy the chips. It's not a big deal. And that's sort of that's sensor networks. That's just one example. And basically, we're still on the same curve that has led us over the last 50 years to computerize more and more granular activities. So as we can afford to do more, we are going to do more. And then finally, the fun part, technology. So DRAM, disk, flash, the aggregation of these devices, which I think is a really cool problem. Erasure codes, which is something I've gotten very excited about over the last year or so. Interconnects, objects, integration, I'll just go through it. Really great research came out recently that I wrote about on Storage Mojo about DRAM. It turns out that not only does DRAM have an error rate that's thousands of times higher than the vendors have told us for decades. Funny how that works. They never tell us it has more errors than it really does. It always seems to come out that, that they tell us it has fewer errors than it really does. And the same with array-to-array mean time to data loss. But anyway, I mean, DRAM is going to continue to get faster and cheaper. But now that Google knows about the hard error rate, and one of the really interesting things about this paper was there were part of the research sample was 20,000 Google servers, right, that they were studying to see what the patterns of DRAM error rates were and what kind of errors. Were they hard or soft? Soft errors, it's an alpha particle, flips a bit, what do? Nothing. But if they're hard errors, then you can start doing things. The authors of the paper noted that Google refused to allow them to release the data from this 20,000 machine sample, which says to me, going back to the Google effect, Google's going to be doing some stuff, and it may be software, it may be hardware, it'll probably be a combination of both, to really start handling these DRAM errors more efficiently. And is it going to be a different kind of ECC? Are there going to be ways to retire DRAM pages in the operating system? Who knows? But they've got PhDs working on it, and they're going to figure out something. And that's, is it going to be an OS strategy? Is it going to be ECC? What? It'll be interesting. Disks. For decades, disks just got smaller because the density would get to a point where the disk was larger than anybody needed, and so they just make it smaller and cheaper and more energy efficient and all the good stuff, lighter. But they've reached the end of the path. They've reached the end of that road in the disk drive industry. So now disks are getting thinner. And it'll be interesting to see how much thinner disks can get. I was very impressed with Hitachi HGST's announcement of helium-filled disks. And helium, being so much lighter than air, produces less turbulence and less drag. And so with a standard 3.5-inch drive, instead of having 5 platters, they're going to be able to have 7. So we're going to be seeing at least 6 terabyte drives, maybe more next year, that have helium in them. And technically, it's quite a feat because helium is not something that likes to stay contained. It's very small molecules. Anyway, so we're going to see thinner drives, but clearly drives can only get so thin, right? You got 1 platter, 2 heads. There's going to be a limit. And of course, they'll keep increasing the density. But as the density grows, so does the bandwidth, which is all good. I think the real big opportunities for the disk drive people are in hybrid drives. And clearly, big vendors, probably PC vendors, have placed enough orders so that now Toshiba, Seagate, and WD are all committed to produce hybrid drives. And it'll be interesting to see, the competition there, because there really is a lot of opportunity to do advanced things with the algorithms that, trade off between flash and hard drive. And then a particular issue of mine that I've been pushing on for years, I think drive vendors have an opportunity to create archive drives. Seagate created a disk drive for General Motors that was supposed to be for in-car use that had a 10-year warranty. Clearly, drive vendors know how to make drives that you can shut off and leave off for a long time, effectively that you could use like tape, but that would have random access. So I think there's an opportunity for the drive vendors, and I'm just concerned that they have very conservative marketing at all the drive vendors. Basically, until they get an order for 10 million units, they're not going to do it. But archive drives play very nicely with their whole end-user focused business, which for all 3 drive vendors is growing very fast and is much better margins than just selling raw drives. So you'd think they'd get excited about archive drives, but hasn't happened yet. Okay, flash. Now, you've heard a lot about flash this morning. I didn't hear it because I wasn't here for most of it. So, but what I see happening is the market is maturing rapidly. There are fewer new players, and I think we're going to see a shakeout where a bunch of people who kind of got into it because You know, at the beginning, the barriers of entry were low. Nobody knew what they didn't know. And it was easy to put together a controller chip and, you know, go to market, and you could sell a bunch and make some good money. So there's going to be fewer new players. I think there's going to be some significant consolidation. I mean, there's only room for a couple of low-price leaders like OCZ in the consumer space. And then I think also right now, like disk drives were 15 or 20 years ago, there were wide disparities in performance and reliability and stuff. But those disparities got reduced a lot over the last 15 years. And I think we're already starting to see that with flash. And I expect to see over the next 5 years a lot more of that. Because there is a lot of concern out there. Flash is not as reliable. Flash drives, consumer flash drives, have not been as reliable as the industry claimed. Shocking, I know. And as a result, people are getting very skeptical. Consumers are getting very skeptical about consumer flash drives. So, you know, there's going to be players that get lost, that get pushed aside, and people who have a good story and a good record are going to do very well, and the people who don't are going to be out of business. I also see the niches really stabilizing for flash. You know, is it going to be a cache? Is it going to be a cache on the motherboard, on a PCI card? Is it going to be a cache on a disk? Is it going to be a cache on an array? Is it going to be a primary storage tier? And where is that going to be? And could be any of these places. And then its use in arrays, I think, is also going to stabilize. But it's a slow process, and I'm really looking forward to somebody doing something really creative, because I'm not an engineer. I don't think about how you could use it, but I always look for creative engineers who do. So that's kind of the device level. I think at device aggregation level, or storage arrays, really, are we seeing any new RAID arrays? Is anybody announcing new RAID arrays as opposed to just revving their existing products? I don't think so. So I think the RAID array business is definitely winding down. I don't think it's going to go away, but there are just major problems with it these days. RAID 5 and 6 are not even close to optimal for data protection anymore. Rebuilds, if you're using large SATA drives, take forever. If you really want high performance, you might as well buy, you know, Violin or Pure or Nimbus or any other vendors here I'm missing? There we go. Just trying to give a little bit of a plug here. So if you want really high performance, you don't need the 15K drives anymore. And RAID 5 and 6 just, you know, don't cut it. It was great technology 20 some odd years ago when Patterson and Katz and Gibson wrote the RAID paper, but there have been really great advances in the underlying technology. Another thing I see happening is that migrations are getting less and less feasible. You know, network speeds and interconnect speeds are not keeping up with the growth of capacity, and that's just going to continue. So we have to figure out a way that people can build infrastructures where they don't have to migrate. Yeah, they keep feeding in new disk drives and you know, new packaging and stuff, but they don't actually have to migrate their data. And then finally, the Drobo model. This is kind of plays off the automation everywhere idea. You know, you can argue about the Drobo architecture, but the Drobo ease of use, the amount of automation that is built into the system, I think it's an idea whose time has come. And we're going to see a lot more of that with advanced storage devices, storage arrays in the future. And one of the reasons for that is the advances in erasure codes. Now, RAID 5 and 6 are built on Reed-Solomon erasure codes. And that was, you know, pretty much state-of-the-art technology back in 1989 when the first RAID systems were built and the RAID paper was written. But over the last 10 years or so, rateless erasure codes have really developed, and there's still development going on with them, some really interesting work. Basically, rateless erasure codes are much more efficient than Reed-Solomon, and they give you much more control over the amount of redundancy that you have in your system. So you can have, let's say, you can survive 4 failures with only a 50% capacity overhead, which is pretty amazing. And there's still room for innovation. I did a post recently on what Windows Azure is doing with erasure coding, and they've come up with a concept of global plus local, well, I guess parity is one way to describe it, coding, so that they can very efficiently survive 3 failures and almost all 4 failures. And that's the kind of innovation that I love to see. And I think we're still at the beginning of a lot of people thinking about these erasure codes. And it enables new aggregation strategies. You can, like Drobo, you can have drives of different sizes. You can spray your data over lots of different drives. They can be different speeds, different sizes, different vendors, different geographic locations. It really gives you a lot more flexibility, and I think there's going to be a lot of creativity there as people play with it. Interconnects, well, let's see. They're going to get faster. That's not a surprise. I think there's going to be more of a split between interconnects that focus on latency and interconnects that focus on bandwidth. Of course, InfiniBand would argue we do both, and they do. They do a good job. But there's cost trade-offs associated with that. But the WAN is really the problem, and big data is only going to make that worse. And somebody needs to figure that out. And I know there are people working on the problem, but big data is really having an impact on the WAN, and I don't see exactly how we're going to fix it, but it's clearly a market need. Okay, so in conclusion, Stephen, how much time did I have up here?
You got as much time as you need, buddy.
Okay. Well, I got some stories to tell you people. No. So anyway, what it all means. Okay, what's going to happen in the next 5 years? Well, the RAID array business is going to coast to steady state. And by steady state, I don't mean it coasts to nothing. It's going to look a lot like the tape library business does today. There's some interesting stuff happening with tape libraries if you're interested in tape libraries. But it's not, it's not a mainstream thing that people who need to buy tape libraries know they need to buy them. They know what they need. They've got a pretty good idea. It's a contracting market. It's not really a growing market. And I think that's where RAID arrays are going to go. RAID arrays are clearly, there's been a lot of engineering to make them really fast, and there's reasons that people are going to keep buying them for years to come. But it's not where the action is going to be in the future. Where one area is going to be object storage going mainstream. Really, why do we even, object storage is something that probably everybody can use once we figure out the algorithms for it, and there's no reason you can't have a $2,000 object storage system instead of a $2,000 NAS filer. And the fact that you can easily add to it means that it's going to be a much more flexible infrastructure than your basic NAS box. I've bought several arrays over the last 5 years, and after 2 years, it starts feeling small because I can get something so much larger. And of course, I store a lot of junk on them. And I think this is a problem that is going to get addressed at the consumer level sometime in the next 5 years. It's a step beyond where Drobo is. Drobo is a limited number of slots. Love what they do, but I think if you could actually create a modular storage system that for Soho and SMB, that this could be very powerful. Then Flash is going to get integrated everywhere. It's inexorable. It just has some serious advantages, which you've probably heard a lot about already this morning. And I think erasure codes are going to continue to advance in efficiency, supported by Moore's Law. And what that means is that these erasure codes are not like free, right? They soak up a lot of CPU cycles. And thank goodness the folks at Intel are providing us with a lot more CPU cycles. So I think there's definitely going to be advances in erasure codes, and there's going to be levels of computation associated with that that would have been prohibitive even 3 years ago, that are going to just be part of mainstream devices within 5 years. So the net is much more sophisticated devices, products that are faster, cheaper, more reliable, more flexible, and a lot easier to use than what we have today. Oh, one more thing. The real fly in the ointment with all of this stuff, right, is the enterprise uptake and consumer uptake. Accelerating innovation only works if people are buying it. And you know, how long does it take to cross the chasm from, you know, interesting technical experiment or demonstration to an enterprise class product? And as near as I can tell, enterprises are starting to move faster than they used to. It took Isilon roughly 9 years to cross the chasm to their $2+ billion acquisition by EMC. Now they ran into some turbulence. You know, they hired some CEO from EMC who turned out to be a jerk, and that created some serious problems for them with you know, accountants and, you know, financial analysts and Wall Street, those people. But still, it probably wouldn't have been that much faster for them, even if they hadn't had that happen. Nimble Storage, which I kind of, one of my favorite companies, but they're not here today. Oh well. You can tell them I said so. It looks to me like they're set to cross the chasm in about 4 years. Now, it's not like it's easy. There's a lot of needles you have to thread to do that. But it really looks like people are moving faster. Now, why are they moving faster? And that's the Google effect, right, and Amazon. Because CFOs may not know an erasure code from a hard drive, but they can look at a price. They can look at dollars and go, geez, it's cheaper over here than it is here. What's the matter with you guys? And that is creating, that's a gravitational pull on the entire industry for the next, you know, probably 20 years. That is going to affect how enterprises, how quick and how flexible enterprises are about adopting new technology. And it's really the effect of the public clouds on the overall perception of what IT should cost. And the days of 60% gross margins are not over, but you're going to have to work a lot harder to earn them. And your life will be simpler if you can figure out how to do it like at 45% gross margins. Anyway, and that's my take on the next 5 years of data storage and what's going to be affecting the industry. Any questions, comments, disagreements? Sir?
So you talked about Flash. What's likely to happen in Flash? What's going to take over from Flash? When do we see that happening?
Well, right now, you know, I think ReRAM, resistance RAM, is going to replace Flash in the enterprise eventually. The question is when. And the thing that I keep seeing is that the vendors who are talking about producing ReRAM basically say, okay, we're gonna have, you know, we're gonna be sampling next year and we're gonna go into production the following year, which is vendor speak for if we can find a customer, we're actually gonna start shipping this stuff. But they haven't found a customer yet. So it's not clear to me, you know, when resistance RAM is actually going to start coming out in the market. You know, HP's made a lot of noise about their version with the memristor, and you know, God bless them. But it really scares me when the guy at HP who's making the most noise is the head of HP Labs and not the head of the server unit. When the head of the server unit says, memristors, you know, kick butt, we're going with them, it's great, competitive advantage, we're gonna mow down, you know, Dell and, you know, PowerPC and everything like that with memristors, then you know you've got something. So I think it's gonna happen, I think it has to happen, but you know, Flash has incredible momentum from all the fact that 90% of it goes into consumer devices and not into enterprise type storage. So there's a huge amount of investment, huge amount of production capacity, and that momentum is going to take a while to overcome.
Yeah, I've heard something will replace Flash immediately after Apple puts it in the next iPad.
Yeah. Yeah, of course, we'll never hear Apple going, yeah, we're going to do this. They'll just announce it one day. And they probably won't even mention what it is, right? You know, they'll just say, hey, it's better. And, but of course, consumer devices don't need the kind of durability and reliability that enterprise devices do. So I think resistance RAM is a long ways away from consumer devices unless there's some kind of amazing price breakthrough. Going once, going twice. Well, thank you very much for your time and attention. And I just want to say, hopefully you'll hear this for the last time for the next 18 months. My name is Robin Harris, and I approve this message.